Hi Flashes, today we are going to be reviewing slope as a rate of change. So this first question here says the following represents the graph for a helium balloon's flight. So question A says determine the rate of change of the graph. Now we need to remember that rate of change does mean slope. So whenever they're asking for the rate of change, we're really just finding the slope of the line. But when they say rate of change, we need the slope to be a unit rate. So unit rate means that you have your denominator as 1. Alright, so remember to find slope of this line, you just need 2 points on the line that cross that intersection. So let's say I use these first 2 points. And remember, slope is rise over run. Rise over run. So we're trying to figure out how far up do we go to get to our second point, and then how far do we run to get to our second point. So notice how we rose 1,000 because we went from 0 to 1,000. So we rose 1,000 and we ran over 1. So that means that our slope is 1,000 over 1. And notice how this is a unit rate because we have our denominator as 1. Okay, part B, what does the slope rate of change mean? So we need to figure out what is the 1,000 representing and what is the 1 representing in this problem. Well, notice how when we went up 1,000, that was talking about feet. So this is 1,000 feet. And when we ran, that was talking about minutes. So what our slope is representing is for every minute, the balloon will rise 1,000 feet. So for every minute, the balloon will rise 1,000 feet. And as always, you guys know that you can pause this video, but I am going to go ahead and move on. So part C says, when is the balloon at 5,000 feet? Show this on your graph. So over here, we're going to see where 5,000 is at. So 5,000 is right here. And I'm going to figure out at what minute was the balloon at 5,000 feet. So all that I'm going to do is I'm going to see where does my line cross at on this 5,000 feet. And it crosses at this point right here. So at what minute is that? Well, go down here. It is at minute 5. So at 5 minutes, the balloon will be at 5,000 feet. All right, part D, this is a little tricky. So it's wondering how high is the balloon off the ground at 2 seconds? And they want you to show this on your graph. So notice how our graph is in minutes and we need it to be in seconds. So what we are going to have to do is we are going to have to convert our slope into seconds instead of minutes. So let's review how to do this. So right now our slope was talking about 1,000 feet per 1 minute. So if I want to convert this into seconds, I need to figure out how many minutes or how many seconds are in a minute. So let's think about it. How many seconds are in a minute? There are 60 seconds in a minute. So if I want to get rid of this minutes here, we have a cross-canceling method. So if I want to cross out minutes to make it into seconds, I need to cross-cancel to make sure that my minutes go away. So if there's 60 seconds in 1 minute, I just need to put this as a fraction. So since I need minutes on top, 1 was talking about the minutes, which means that my 60 will go on bottom, and this would be talking about seconds. So all that I'm going to do is multiply across. So 1,000 times 1 is 1,000. 1 times 60 is 60. And then if I were to divide this to be a unit rate, 1,000 divided by 60 gives me 16.6 repeating, and since we're talking about feet, I'm just going to leave it as 16.7. So I'm going to round it to the nearest tenth. and it would be over 1 second, okay? So we converted our unit rate, our slope, our rate of change into seconds, okay? So now for every second, the balloon will rise 16.7 feet. The question, though, is asking how high is the balloon off the ground at 2 seconds? Right now it's at 1 second. So if I want to figure out 2 seconds, what do you guys think I should do with the 16.7 and the 2? I should multiply it. Very good. So all that I'm going to do in my calculator is take 16.7 times 2, and that will give me 33.4 feet per 2 seconds. Actually, I won't even put the 2 seconds. I'll just put the 33.4 feet. Okay, so at 2 feet, the balloon will be at 33.4 feet. And they said to just show this on your graph, so this is going to be kind of close to 0 here, so I would just put that point about right there. Alright, moving on to the next one. Although it's not on the graph, when will the balloon reach 10,000 feet? And show your reasoning. So when I have a question like this, I have 3 numbers. Think about what is something that I can set up in order to solve this. If I have 3 numbers and I'm looking for a missing one, well, I can set up a proportion. So you start with your slope, your original slope that you had, which was the 1,000 over 1. And if I'm trying to figure out when the balloon will reach 10,000 feet, remember in proportions, everything has to be aligned. So which one of these numbers was also talking about feet? The 1,000 was. So since the 1,000 was also talking about feet, that means that the 10,000 will also go in the numerator. And then we are trying to figure out when will the balloon reach that, which means my x will be in my denominator. So let's go ahead and solve this. So 1,000 times x is 1,000x. 10,000 times 1 is 10,000. And remember, guys, to get x by itself, all that we're going to do is divide by 1,000 on both sides. So in my calculator, I'm going to take 10,000 divided by 1,000. And notice how we get 10. So our answer here is going to be 10 minutes. So at 10 minutes, the balloon will reach 10,000 feet. Another way to do this, guys, is if the balloon rises 1,000 feet per minute, just take this 1,000 feet times 10, and then you can get the same exact answer. Alright, and then question F, why is the graph only in quadrant 1? So remember your quadrants on a coordinate plane. Quadrant 1 is in the top right corner of your quadrants, and quadrant 1 is only represented by positive numbers. So that is why this graph is only in quadrant 1, is can we have negative minutes? Is it possible to have negative minutes? No. And is it possible to have negative feet? No. So down here, you could just write you can't have negative time or feet. All right. Moving on to our second part. So the following represents the balance in Brady's savings account. First thing says to find the slope of the graph. So you could pick your own 2 points, or you can pick the 2 points that they have for you. But let's say I pick my own 2 points because I like to pick ones that are close together. So I am going to use these 2 points. All right. So remember, when you're finding the slope of the graph, you're finding the rise over the run. So if I start here at 300 and I'm rising to get to the second point, and I went up 100, so notice how I went from 300 to 400. That means that I rose 100, and then I ran over 1 because I start here at 0 and then it went to 1. So that means that my slope is 100 over 1. Okay. And then what does the slope represent as a rate of change? Well, remember, we need to figure out what do these numbers mean. The 100, so when I rose 100, that was talking about dollars. And then when I ran over 1, that was talking about my x-axis, which was talking about months. So this means for every month, Brady saved $100. Okay. Question C, how much did Brady deposit when he opened the account? So as soon as he opened the account, how much money did he put in there? Well, look at where your line starts. It starts right here at 300, so that means that as soon as Brady went in, he deposited $300 into his bank account. All right, next one. At this rate, how much money will Brady have in his account after 15 months? So there's a couple different ways that we can do this. We can set up a proportion again, okay? Or let's think about it this way. So if he puts in $100 every month, okay, and we're trying to figure out how much he'll have after 15 months, well, all that we can do here is figure out how much he puts in after 15 months is to just take that 100 times 15, which will give us that 1,500, okay? However, this is not our answer, okay? This would be our answer if Brady started with $0 in his bank account. However, we just said that he started with 300. So after 15 months, he deposits 1,500, but he deposited 300 in his bank account when he opened it. To get our final answer, what do you guys think we're going to have to do with these two numbers? We're going to have to add them. Okay, so our final answer here should be $1,800. So he'll have $1,800 in his bank account after 15 months because he started with 300. Then he's going to add in $1,500 after 15 months. So altogether, he's going to have $1,800. All right. If Brady deposited $500 to begin with, but continued to deposit the same amount each month, what will this graph look like? So instead of starting here at 300, he will start here at 500 when he deposits his bank account. And then if he still puts $100 in every month, it's still, his graph is still going to go up 1 and over 1. Because we rose 100 and we ran 1, so that means that he's still putting in $100 each month, and his graph will look something like this. And that's done. All right, next one. If Brady deposited 300 but spent all of it in 5 months, show this on the graph. So he still is going to start here at 300, but after he spends all of it in 5 months, how much money is he going to have left? Well, he's going to have 0. So instead of having a positive slope, because he's not putting money in his bank account, he's actually going to lose it after the 5 months. So at 5 months, he's now going to have $0 in his bank account. So my graph should look something like this. He starts at 300, and then after 5 months, he'll be at $0. All right, part G, what would the slope of this line be? What does the negative sign indicate? Well, let's figure out what the slope is. So let's say I use the 2 points that I created here. And remember, when you're finding slope, you're finding the rise over the run, but notice with this line, if I'm trying to go from this point to this point, I can't rise because then I'm getting further and further away from this point. So if I can't rise, that means that I have to fall. And when I fall, remember that that means that my line is negative and my slope is going to be negative. So let's see, how far do I fall to get to this point? Well, I start at 300 and I went to 0. So that means that I fell negative 300. so negative 300. And then how far did I run? Well, I started at 0, and then I went over 1, 2, 3, 4, 5. So that means that my slope is negative 300 over 5. But remember, we always need to simplify. So when I simplify this, negative 300 over 5, I can divide both of these numbers by 5, and that is going to leave me with negative 60 over 1. All right, so what does the negative sign indicate? Well, the negative sign means that he's not depositing money anymore. That means that he is withdrawing money. So he's taking out money. Alright guys, and then this last one here, is the graph proportional or non-proportional, and explain why. So remember, in order for a graph to be proportional, it must be a straight line and it must go through the origin. So notice how the original line is a straight line, okay, so it was a straight line. However, our line did not go through the origin. It did not go through 0, 0. So we would say that this graph is not proportional, because it doesn't go through the origin. All right, moving on to our second page. All right, so Rohan makes $7 per hour babysitting. Create a table of values and graph for this scenario. Find the rate of change and the equation, and what does it represent? Okay, so if he makes $7 per hour babysitting and he worked for 0 hours, how much money is he making? $0. If he's not working, that means that he's not making any money, okay? After 1 hour, if he makes $7 per hour babysitting, that means that he'll make 7. After 2 hours, 2 times 7 would be $14. After 3 times 7 is 21. After 4 times 7 is 28. And then after 5, 7 times 5 is $35. Okay. So remember guys, when we create a table, this is really creating order pairs for us. So like this is the order pair 0, 0, 1, 7, 2, 14, 3, 21, and so on. Okay. So they want us to graph this over here on this graph. So our x values are talking about time. So I'm going to put time down here. And we're just counting by 1, so I'm going to do the same thing down here at the bottom, as I'm just going to count by 1s, because we can create whatever numbers we want, whatever values. I'm just going to use the ones that make the most sense, okay? So our x value down here is talking about time, which means that our y value was talking about money made. And there's a couple different ways that we can do this. Since we are counting by 7s, I'm just going to count by 7s as well to make it easier for me. So I'm going to go 7, 14, 21, 28, 35. And then let's just start graphing these. So we do have a point at 0, 0. Then we have a point at 1, 7, 2, 14, 3, 21, 4, 28, and 5, 35. All right, so first thing they're asking here is find the rate of change and then create your equation from it. So remember, rate of change, we can either find the slope of the table, or we can find the slope of the graph. Does not really matter here. Okay, so let's say I want to find the slope of the table so that we can practice that, since this does show up on quizzes and tests. So remember, when you're finding slope of a table, you are looking for your change in y's over your change in x's. So since our y-axis was talking about money made, let's first look at our change in y's. So when we went from 0 to 7, we rose 7. 7 to 14, we rose 7. 14 to 21, we rose 7. 21 to 28, we rose 7. And 28 to 35, we also rose 7. So notice how our change in y's were 7 every time. So that means that our rise was 7. And then your change in x's, so we're going to do the same thing over here with our time. We went from 0 to 1, so that's plus 1. 1 to 2 was plus 1. 2 to 3 was plus 1. 3 to 4 was plus 1. And 4 to 5 was plus 1. So since our change in x's were all the same, that means that our change in x's were 1. So that means that we have a rate of change of 7 over 1. And remember, rate of change is the slope, so we also could have found the slope of this graph over here. So notice how if I pick my first 2 points, if I went from 0 to 7, that means I rose 7. And if I went from 0 to 1, that means I ran 1. So we would have gotten the same exact thing as 7 over 1. Okay. Then our equation, so remember our equation is in the format y equals kx, where k is your slope. So since we just found our slope to be 7 over 1, I'm just going to put 7 over 1 here for k, and I'm going to leave y and x. So our equation is just going to be y equals 7 over 1x, and that's it. All right, and then this last question here, B, it's asking what does the slope represent? So remember, we just need to figure out what is the 7 talking about and what is the 1 talking about. So our 7 was talking about the change in y's, which was the money made, so money. And our change in x's, the 1 was talking about hours. So what does our slope mean? Well, it means for every hour, Rohan makes $7. And that's it. And I know this question is not on here, but notice how this is a proportional relationship because our graph goes through 0, 0, and it is a straight line. All right, next one. If it costs $25 to rent a car and 10 cents per kilometer drive, create a graph for this scenario. Hint, even if you do not drive the car off the lot, it will still cost you $25. Find the rate of change of this graph. Okay, so what we are doing here is we are starting at $25 because it says even if you don't drive the car off the lot, so that means 0 distance, you still have to pay $25. So they went ahead and they paid that $25 for us. Now to figure out how much it'll cost after 10 kilometers, well, I can create an equation from this, and you guys won't have to do this on your quiz, so I'll just go ahead and show you guys what this equation would be. Is if it's saying that it's going to cost us 10 cents per kilometer, that just means I'm going to take 0.10 times the kilometer distance that we're talking about here, and then I'm just going to add the extra $25 that we're going to start with. So for this one, if I'm going to plug in 10 for K, I'm going to take 0.10 plus 25 to figure out how much it's going to cost. So 0.10 times 10 is 1. And then add that additional $25 and we get 26. Okay. So now we're going to do the same thing with 20. So I'm going to take the 0.10 that it costs per kilometer and multiply that times 20. And then add the original $25 that we began with. So 0.10 times, not 25, 20 is 2. So 0.10 times 20 is 2. And then plus the additional 25, and we get 27. And hopefully you guys can see what the pattern is going to be here. So this was 25, 26, 27. And if we keep continuing the process, it's going to be 28, 29, and 30. So let's go ahead and graph this scenario. So our x value is talking about distance in kilometers. And our y value is talking about the cost. So since our distance is counting by tens, I'm also going to count by tens. And since our y value is talking about money, and it starts at 25 and goes to 30, I think I'm going to, let's see here. So there is a way to show that I am skipping part of a graph to get to 25. And you guys don't have to know this, but it does look something like this. So I am still going to count by ones, but I'm just going to show you guys that I'm skipping 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and all the way up to 25 because I just want to start at 25 and then count from ones after that. All right, so let's graph this. So at 0, 25, we'll have a point, 10, 26, 20, 27, 30, 28, 40, 29, and 50, 30. All right, so let's find the slope of this graph. So again, you can find slope by doing rise over run over here, or you can find the slope by looking at your change in y's over your change in x's. So here, our change in y's, notice how when we go from 25 to 26, 26 to 27, 28 to 29, and 29 to 30, we just went up by ones every time. So our change in y's are going to be 1 over our change in x's. Notice how our change in x's, we're going up by tens every time. So our change in x is going to be 10. So that means that our rate of change is 1 over 10. And then if you wanted to create your denominator to be 1, because we are talking about a rate of change here, remember you're just finding the unit rate. So we're taking 1 divided by 10, and we get this 0.1. All right, so what does this represent? So you could use this formula or this slope, doesn't matter. Remember the 0.1 was talking about cost, or the 1 was talking about cost, and our denominators was talking about distance in kilometers. So what does it represent? You can say for every 10 kilometers it costs $1, or you can say for every 1 kilometer it's going to cost you 10 cents. And I didn't leave myself enough room, so I'm going to do it on the side over here. So for every 1 kilometer, the cost is 10 cents, so 0.10. So for every 1 kilometer, the cost is 10 cents. And that was for B. All right, C, what is the value on the y-axis and how does this relate to the scenario? So remember our y-axis is our vertical line that's going straight up and down. And if you notice, our graph started right here at 25 and that point is on the y-axis. So the value on the y-axis is 25. And what did the 25 represent in the story here? Well, it said that it was just $25 to rent the car. So the 25 was just representing renting the car. All right, part D, if you paid the same fee to rent the car, but more per kilometer, what would this look like? And sketch it on the graph. So if we were to sketch this on the graph, so we're still starting at the 25, but if we were paying more than just the $1 per 10 kilometers, it's going to be a line that is just going to have a greater rate of change. So it would look something like that. So it's just going to go up higher at a faster rate because we would be paying more per kilometer. All right, and E, is this graph proportional or non-proportional, and why? Well, the original graph, it is a straight line. However, did it start at the origin? Did it start at 0, 0? It did not. So that means that this graph is non-proportional because it didn't start at the origin. Alright, moving on to our last page here. So 5A says, what is the slope of this graph? Well, our slope is just a horizontal line. So if you guys remember Slope Dude, remember when he was going on that flat line part, he was saying this is zero fun. So remember, when you have a line that's going horizontal, that means that you have a zero slope. So this equation, so remember our equations, y equals kx. K is our slope, so if we had a slope of 0, I would just plug in 0 for k, which means our equation would just be y equals 0x. And I don't want to put the equation here in this situation, so I'm actually going to cross that out because we're only going to deal with the equation when we're talking about proportional relationships. So since this graph does not go through 0, 0, I'm not worried about the equation. Okay, part B, interpret what this rate of change means. Well, if we are talking about weeks here and books, that means that this person has only read one book for this amount of weeks. So you can just write that as a sentence. So this person has only read one book for multiple weeks. And you can just put something like that. Okay. So B and C are really asking the same thing, so I'm just going to skip C and then move on to D. So how many books has this person read in 2 weeks? Well, at 2 weeks, they still have only read one book. And then at 8 weeks, same thing. At 8 weeks, this person has still only read one book. Okay? All right, and our last question here. So what is the slope of this graph? Again, I just need 2 points that cross that intersection, so I'm going to use this point and this point. And remember, slope is rise over run, so how far do I rise to get to my second point? I go up 1, 2, 3. And how far do I run? I go over 1, 2. So that means that my slope is 3 over 2. Part B, interpret the slope as a rate of change. So I just need to know what was the 3 talking about and what was the 2 talking about. Well, the 3 was on the y-axis and it was talking about money. And the 2 was on my x-axis and it was talking about miles. So when I go to interpret the slope, that means for every 2 miles, it costs $3. Part C, what is the cost if the distance is 0? So our distance is 0, and where does the line cross at? Right here. So at that point, it was $15. Part D, you just have to create a story for this, so I'm going to skip that and let you guys try that one on your own. And then again, part E, why is this graph only in quadrant 1? Well, quadrant 1 is only talking about positive numbers, so was it possible to have negative miles? Nope. Is it possible to have negative cost? Nope. So that's why it's only in quadrant 1. So you cannot have negative miles or negative money. And that's it. So if you guys have any questions, please let your teacher know.